Welcome to True Projects. In this video, we are going to explain about the project, which is real and fake face detection using deep learning and Streamlit. Coming to the introduction of the project, a fake face is an artificially generated or manipulated image that resembles a real face, but it is created using digital editing tools or deep learning algorithms. These fake faces can be used for malicious purposes, such as identity theft or spreading misinformation. This project focuses on developing a system to automatically distinguish between real and fake faces using deep learning techniques. By detecting fake faces, we aim to mitigate the risk associated with the proliferation of manipulated or synthetic images, including misinformation and identity fraud. Traditional methods for face detection and verification often rely on handcrafted features and algorithms, which may not be robust against sophisticated manipulation techniques. These methods may struggle to accurately detect fake faces generated using adversarial networks, which are GANs. Moreover, traditional approaches may require manual intervention or human expertise to verify the authenticity of faces, making them impractical or large scale applications. The proposed system utilizes deep learning models trained on extensive dataset of both real and fake faces to automatically differentiate between them. By utilizing convolutional neural networks or other deep learning architectures, we extract high-level features from faces and learn complex patterns associated with real and fake images. And the project is deployed with Streamlit enables users to upload images and receive real-time feedback on face authenticity. This user friendly tool empowers informed decisions about online content, mitigating misinformation spread, and safeguarding against harm. Deep learning plays a pivotal role in advancing face detection and recognition, particularly in detecting fake faces. Deep learning models demonstrate exceptional performance in learning discriminative features from raw data, enabling effective differentiation between real and fake faces. Furthermore, deep learning techniques can continuously evolve and adapt to new challenges by leveraging large scale datasets and computational resources, making them highly suitable for addressing the evolving threats posed by fake faces across various domains. Coming to the objective of the project, the objective is to develop a robust system for real time detection of fake faces in images, addressing the increasing concerns surrounding the proliferation of manipulated visual content on digital platforms. The system will be deployed using Streamlit, enabling interactive web applications for users to upload images and receive real time feedback on the authenticity of detected faces. The goal is to leverage state of the art deep learning algorithms, including convolutional neural network, MobileNet V2, Inception V3, DenseNet, and anti spoof classifier to effectively analyze facial features and patterns and distinguish between real and fake faces. The aim is to classify faces into two classes, which is real and fake, facilitating straightforward identification of whether a given face in the image is authentic or digitally altered or manipulated. The objective is to evaluate the performance of the developed system using standard evaluation metrics with a primary focus on accuracy. By comparing the accuracy achieved by different algorithms and techniques, the project aims to identify the most effective approach for real and fake face detection. The goal is to benefit various stakeholders, including social media platforms, news organizations, law enforcement agencies, and the general public. By providing a reliable tool for detecting fake faces, the project can help mitigating the spread of misinformation, protect individuals' identities from misuse, and enhance overall trust and security in digital communication and media. To implement this project, we need software and hardware requirements. Coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework Streamlit, back-end framework Jupyter Notebook, front-end technologies HTML, CSS, JavaScript, and Bootstrap 4. Coming to hardware requirements, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. To implement this project, we have designed various steps in the flow of work. So coming to the first step, which is importing the packages. This step involves importing necessary Python libraries and frameworks required for the project. We imported TensorFlow for deep learning, PyTorch for image processing, NumPy for numerical operations, Matplotlib for visualization, Streamlit for web application. The next step is importing the dataset. In this step, the dataset containing images of both real and fake faces is imported. This dataset serves as a training data for the deep learning models. The next step is image scaling and processing. Here, the images in the dataset are scaled to a standardized size and undergo pre-processing steps such as normalization, grayscale conversion, or color channel adjustments. These pre-processing steps helps to improve the efficiency and effectiveness of the model training process. The next step is splitting the data into train and test. Here, the dataset is divided into two subsets, the training set and the testing set. The training set is used to train the deep learning model, while the testing set is used to evaluate its performance and generalization ability. The next step is building the model. In this step, the architecture of the deep learning model is defined. This includes specifying the number of layers, activation functions, and other parameters that determine how the model learns to differentiate between real and fake faces. The next step is training the model. The deep learning model is trained using the training data. During training, the model learns to recognize patterns and features in the images that distinguish between real and fake faces. This process involves adjusting the model's weights and biases based on the error between the predicted and actual labels. The next step is Streamlit framework. Here, Streamlit is used to create an interactive web application that allows users to upload images and receive real-time feedback on the authenticity of the detected faces. Streamlit provides a user-friendly interface for interacting with the trained deep learning model. Coming to the next step, which is user gives input, users upload images containing faces to the Streamlit application for analysis. These images can either be real or fake faces. The next step is the given input is pre-processed with a trained model. The uploaded images are pre-processed to prepare them for input into the trained deep learning model. The pre-processed images are then fed into the trained model, which outputs predictions on whether the faces are real or fake. The last step is final outcome is displayed. In this step, the final outcome of the analysis is displayed to the user through the Streamlit interface. This includes information on the authenticity of the detected faces, along with any additional visualizations on insights provided by the applications. Algorithms which are used for real and fake face detection are CNN, which is convolutional neural network. CNNs are deep learning models specifically designed for processing structured grid data such as images. They consist of multiple layers of convolutional and pooling operations, followed by fully connected layers for classification. CNNs are commonly used for image classification tasks due to their ability to automatically learn hierarchical features from the raw pixel data, making them well suited for distinguishing between real and fake faces based on visual features. The next algorithm is MobileNet V2. MobileNet V2 is a lightweight deep learning architecture optimized for mobile and embedded devices. It utilizes depth-wise separable convolutions to reduce model size and computational complexity while maintaining high accuracy. MobileNet V2 offers a good balance between model size and performance, making it suitable for deployment in resource-constrained environments such as mobile apps or web applications where efficiency is important. The next algorithm is Inception V3. Inception V3 is a deep learning architecture that incorporates a module called the Inception module, which allows for efficient feature extraction at multiple scales through the use of parallel convolutions. Inception V3 is known for its excellent performance in image classification tasks, making it a strong candidate for accurately distinguishing between real and fake faces by extracting discriminative features from facial images. The next algorithm is DenseNet. DenseNet is a deep learning architecture that introduces dense connectivity between layers where each layer is connected to every other layer in a feed-forward fashion. This facilitates feature reuse and enables the network to be more parameter efficient. DenseNet has shown promising results in various computer vision tasks, including image classification and object detection. Its dense connectivity helps to capture fine-grained features in facial images, which can improve the accuracy of real versus fake faces detection. The last algorithm is anti-spoof classifier. Anti-spoof classifier is a specialized classifier designed to detect spoof attacks where an attacker attempts to deceive biometric authentication system using fake biometric samples. Anti-spoof classifier is specially tailored for detecting fake faces generated by spoof attacks, making it an essential component in the project for identifying and filtering out such fraudulent attempts to deceive the face detection system. This is the model loss graph of anti-spoof classifiers algorithm. Similarly, we will have model loss graph for other algorithms also, but we are showing anti-spoof classifier algorithm because it is performing well. Here in the graph, it shows the training loss and the validation loss of the model during training process. The x-axis represents the number of epochs, which is one complete pass through the training data, and the y-axis represents the loss, which is a measure of how well the model is performing on the data. Here in the graph, the training loss and the validation loss is decreasing with the number of epochs, which means that it is a good sign and it is performing well. So we have used it for deploying this in the front end, which is anti-spoof algorithm is deployed in the front end. To execute the project, first we have to open the code folder which contains source code files. This is the code folder of the project. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in HTML templates. And these are the model files which contain the algorithm information and that will be loaded into the project code during runtime. And this is the notebook.ipynb file. This is a Jupyter notebook file which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. This is sign-up file. This file is a database file used to store the user information. Now we have to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now we need to open the Anaconda prompt. Here, using the cd command followed by the space, we need to paste the copied path and then click on enter. Here we can observe that current directory is changed to the code folder's path. Here we need to type the command streamlit space run app.py to run the Streamlit app. And now we need to click on enter. This command will execute Python script and launch Streamlit application locally. So it has redirected directly to the web browser. Here in the Anaconda prompt, after running the command, Streamlit will display the local URL where the app is hosted. And we can share this local URL provided by the Streamlit with others on the same network so they can access and interact with the app. Now get back to the web application. This is web application of the project, which is launched by Streamlit. With this, we are going to detect whether a face is real or a fake. Here we can see browse file button. We need to click on that for uploading the images. So I'm clicking on browse files button. From the test cases folder, I'm uploading the first image to detect whether this face is real or fake. So I'm selecting it, click on open. Here we got the prediction that based on the uploaded image, it is fake image. Now we will try giving the other face. So click on browse files again. We will upload last image. Click on open. Here we got the prediction that the uploaded image is a real image, which means it is not a manipulated image. It's an original image. Now we will try uploading the other image. Click on browse files. I'm going to upload this image. Click on open. So here we got the prediction that the uploaded image is a real image. Now we will upload one more image again. I'm uploading the second image. Click on open. So here we got the prediction that the uploaded image is fake image, which means it is manipulated or the altered image. Now we will try uploading the other image. Click on browse files. This time we will upload the seventh image. Click on open. Here we got the detection that the uploaded image is real image. Now we will upload one more image. Click on browse files. I'm going to upload the fourth image. Click on open. So here we got the prediction that the uploaded image is fake image. In this way, just by uploading the images to the system, then the system will detect whether the image is real or fake. Conclusion of the project is the project has been successfully developed, achieving its primary objective of creating a system for real-time detection of fake faces in images deployed using Streamlit for interactive user interface. Among the algorithms evaluated, the anti-spoof classifier demonstrated superior performance in accurately detecting fake faces, highlighting its effectiveness in mitigating spoof attacks. The project utilizes anti-spoof classifier algorithm as a primary component of the face detection system deployed with Streamlit to provide users with a user-friendly interface for real-time feedback on face authenticity. The project opens up avenues for further research and development in field of face detection and authentication. Future enhancements could include incorporating additional deep learning architectures, improving model robustness against emerging spoofing techniques, and expanding the system's capabilities to handle a wider range of multimedia content.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.